Hello. In the previous video lecture, we have discussed about basic definition of NFA, that is Non-deterministic Finite Automata. The name itself very clear, non-deterministic, which means not clear. What is the next state? We are not clear. Then practically we need deterministic, DFA only. So designing NFA is simple, easy, because it can be anything. So let us first design with NFA and then convert that given NFA to DFA. This is the usual procedure we do follow, and it is simple also. Conversion from NFA to DFA. There are two methods. The first one is subset construction method, and the next video we will see lazy evaluation method. Design NFA. First I am going to design NFA which accepts strings of zeros and ones that ends with 0. After designing, convert that particular NFA to DFA using subset construction method. Step 1. Defining minimum value, that is ends with 0. Everywhere it is ending with 0. We are going to draw NFA for that. So 1 0 is required. Ready. Since it ends with 0, starting can be anything. 0 or 1 can be anything. Next, what is its table? Transition table for NFA. If we do transitions table for Q0 0, it can be Q0 also, it can be Q1 also. So it should be within braces Q0 comma Q1. Especially whenever I put these braces, it should be NFA. That is for multiple states. It can be Q0 also, Q1 also. For Q0, 1 will be Q0. So it should be Q0. For Q1, 0 also, 1 also not there. So it should be null. So we are ready with the transition table of NFA. So always define NFA, draw the state diagram for NFA, give transition table. Over. Now convert to DFA. Once step 2 is over, transition table of NFA is ready with initial value and final value. Convert that to DFA table. This is your NFA table. Convert that to DFA table. How to convert to DFA table? Very simple. Come on. How many states are there? 2 states. 2 power 2. We say 2 power Q. Q is equal to 2 now. So you should have 4 rows here. In case if I have 3, 2 power 3, 8 states are there. 4, 2 power 4, 16 states. Definitely it is very difficult to do the calculation. So subset method is not a successful method. We have to go for lazy method. Anyhow, we will conclude this particular subset method. I brought 4 rows. Reason 2 power 2 is 4 states. What should be that 4? Can you recall? Null, Q0, Q1, Q0 comma Q1. This is what we discussed very long back. Okay. Null, Q0, Q1, Q0, Q1. This put together it is a one state. Once a bit square bracket, put together single state. If you do braces, it is 2 individual states. Q0 also, Q1 also. So remember, these are all the basic definitions. Now, how to find out? Check each value in NFA. I need answer for Q0. Okay, sir. Check each value in NFA and fill its transition for DFA table. What is that meaning? I need answer for Q0. Yes, sir. Go to NFA table. Okay. For that, for 0, what is the result? Q0 comma Q1. Put together, you put it in square bracket. So remember, braces is NFA, square bracket is DFA. If you put braces, Q0 also, Q1 also, multiple state. If you put square, put together it is a single state. Q0, Q1 is renamed as a single state. That's what the meaning. Okay. For Q0, one result, what is the answer? Q0. So obviously what should be the answer here? Q0. Done. Now let us go to Q1. For Q1 I need in DFA. Okay. Come here. Go to NFA. What is the answer? Copy paste here. Done. Now I need for Q0, Q1. What I should do? Come here. Q0 as well as Q1. So in NFA, 2 different states. what I should do, just merge. What I am going to do, Q0, Q1 for 0, take both answer, perform union. That is what I mentioned here. Okay. Do you want Q0 as well as Q1? Yes, sir. Go here, Q0 as well as Q1, tell its both answer and take its union. Tell me what is the answer for this Q0, Q1. What is the answer for this null? What is union of this Q0, Q1? That should be in square bracket here. Come on. Same thing, go here. Take merging of these two. Take the union. What is Q0 union null? Is nothing but Q0. Ready. So all these things over. Now let us go to null. Since nothing is there, everything becomes null. So this is NFA table. This is DFA table. It's very simple. Identify the values you need. Go here. Analyze. If it is two different groups, make union and come here. But if it is 8 states, difficult. If it is 16 states, very difficult. That's what the problem with the subset method. Now, who is the initial year? Q0. Here also Q0. Who is the final year? Q1. Where and all Q1, that is final. Remember, where and all Q1, that is final. Next. My DFA table is ready. It looks very big. We can reduce it. How? Remove where and all null group. This both are null. This whole row is removed. This both are null. The whole row is removed. If one is null is there, one value you cannot remove. Okay. Ready. So this is removed. This is removed. Ready. Sir, I already told in DFA, if you put square bracket, it is single value. Can you name it as A? A. You can name it. So if you just hide this, already Q0, you can give A also. You can give X also. For similarities, I am going to give Q1 only. Okay. So it is the actual value. I am renaming it as Q1. Nothing wrong about it. Yes, sir. I will rename it as capital A, capital X. It's left to you. Now let us draw DFA for this particular table. So this is NFA. I converted to DFA. I simplified DFA. I am going to draw DFA now. Q0. For 0 it is Q1. For 1 it is Q0. Q1. For 0 also. For 0 it is Q1. For 1 it is Q0. Okay, it is coming back. So we are very clear. This diagram is deterministic. This is called DFA. Now this DFA, since I told A also allowed, B also allowed, X also allowed, I will just show one more analysis here. Rename it as this as A, B, C. This put together D. Repeating A, B, C, put together D. If I do, I will get the same story. A, B, C, D, ready. Where and all this fellow? A, all are A. And this is a D. So this is also D, this is also D. You can make it. And this is B, this is B, this is B. Okay, like that I made it. So with this, I conclude this particular video, which is related to designing NFA problem, converting NFA problem to DFA problem using subset method. Thank you.